Okay, so chapter 10, problem 22, what is the angular velocity, or final, pardon me, what is the final velocity of a hoop that rolls without slipping down a 5-meter high hill starting from rest? So here are the important things. Well, without slipping is very important here. So our hoop starts off at the top of the hill and rolls down, right? Now, if it is not slipping, then the velocity of the hoop at its um, at its edge is the same as the linear velocity of the center of the mass, right? So if it's not slipping, if it slips, then those two aren't related, right? But if it doesn't slip, then we can use omega equals VR, V over R, right? We can use omega equals V over R, and that V is also the V of the center of the mass. All right. If it slips, however, that's not true. If you can imagine, this hill is greased completely so it doesn't even turn because there's nothing to make it turn, and it just slips down. Well, omega is 0, right? But the velocity still is not 0. It's because it doesn't slip that the linear velocity of the hoop and its angular velocity are related. All right, so I'm going to go at this with conservation of energy, right? And so we have the mgh, the potential energy of the hoop at the top of the hill. It doesn't have any kinetic energy yet. Once it gets down to the bottom of the hill, it has no more potential energy, but has 1/2 mv squared, right, plus 1/2 I omega squared. Now, 1/2 I omega squared is the rotational kinetic energy, right? And we just went through omega, because we're not slipping, omega is V over R. Now, if it was slipping, we could still have omega equals V over R, but it wouldn't be the same V, right? We'd have V2. The fact that it's slipping means that these V's are, in fact, the same V's. All right, so omega equals V over R. And I for a hoop is what? I for a hoop, our handy chart, I for a hoop is mr squared, right? mr squared. All right, so if we put this all together, we have mgh equals 1/2 mv squared plus 1/2 of mr squared times omega squared, which is V over R squared, right? Now what do we see here? Mass cancels out everywhere, right? No mass. Okay, R squared and that R cancel out. And so what we're left with is GH equals 1/2 V squared plus 1/2 V squared. That was interesting. V squared, right, equals just V squared. Since we're after the velocity, V equals the square root of GH equals the square root of G is 9.8 meters per second squared, and H is 5 meters. Okay, so square root of 9.8 times 5, I'll fix that in the text here, I get 7 meters per second. 7 meters per second. All right, velocity is 7 meters per second. That's it for problem 22.